Hey guys, so right now we're going to do a little bit of an overview on the harder graph questions. And so we're just going to do one problem, but it's going to encompass the trig stuff as well, so we can get through most of the details, I think, with this one problem. So first we have y equals 3x minus the tangent of x with the bounds that, sorry, this should be here, that x is greater than negative pi over 2, but is less than pi over 2. And what that means is that if you go over to your unit circle, so here's a little axis, here's your unit circle, that means that you can only use the values from this part, because we know that this point here is pi over 2, but that this point here, technically it's 3 pi over 2, but if you start here and then go clockwise, then that equals negative pi over 2. And so your first step is going to take the derivative. So y prime equals 3 minus the secant squared of x. And when you let y prime equal 0, so that's 3 minus the secant squared of x equals 0. Now make that the cosine so you can solve it easier. So equals 0, multiply through, and you end up getting, after you solve that through, you get the cosine of x equals plus or minus the square root of 3 over 3. But we know that if the cosine is negative, then you're going to go into a negative x, but we can't do that because, as we see over here, at the unit circle, that doesn't fall within the domain. So you're going to keep it as the cosine of x equals the square root of 3 over 3. And when you solve that, you get x equals 0.955, which takes care of this line right here. But since your domain goes all the way down to the fourth quadrant, you also have to find what this point's going to be down here. So what you do is you take 2 pi and then you subtract 0.955 from that, which technically would give you around like 0.533, but that's larger than the domain, so you have to express the 5.33 as a negative number, so just express that as negative 0.955. As you can see, the domain's kind of weird, but just know that you have to express it within the given bounds. And so your next step is going to be to take the second derivative of the original equation. So your first derivative is 3 minus the secant squared of x. So then your second derivative will be negative 2 the secant squared of x times the tangent of x. And then you have to let that equal 0. And it's easier to write it as sine x over cosine cubed of x, just so you can use like easier functions. And then you're looking for when sine of x equals 0 or when cosine of x cubed is undefined. And so cosine is never undefined, but sine is 0 at 0 radians and pi. However, pi is not within your domain, so you don't count that one. You only use the 0. So to recap, one critical number is 0, and the others are 0.955 and then negative 0.955. Okay, so here's what the chart would look like for this problem. Now, we already have a basic understanding of how the chart works, so as you can see, we have all of our information here. Not really anything special to note about it, except for if you look over here with, so like with this part. So that's the domain on the graph. But since pi over 2 and negative pi over 2 are not included, you technically don't need asymptotes. Now I put them on the graph just so you can see like that the graph doesn't like keep going like past that point, but because it does have a limit. But since it's not like included, you don't have to put it actually like in your chart and in your graph. So there's no x equals negative pi over 2 and no x equals pi over 2. And just a note, so when over here When you put it into your calculator, you end up getting like a point. I think it's 0.0026 something, but you can just approximate that to 0. And then one more point. Somebody asked me about this like earlier in like last week, and so like you know that this is like a min and max, because if you go from decreasing to increasing like this, then like this is obviously a minimum. And if same thing, if you go from increasing to decreasing, then this is obviously going to be a maximum because it's the highest point. And so this is your graph for y equals 3x minus the tangent of x in Christmas colors because it is Christmas time. And once again, so the asymptotes don't have to be in the chart, but they are there. So, you know, your graph, just to do like a little ghost extension, your graph doesn't go like this because you have crossed the asymptote, and you can't do that. So just keep it to the red and green colors. And so these are your other graphs for the first and second derivatives. Now there's really nothing major to point out here, just once again that like they end at a certain point, but they're not in the it's not within the domain, so you don't actually have to put like the exactly where it ends. And if you have any more questions, then text me or a member of the math team. Thank you.